Okay, I think we're going to get started. Thank you for joining us for the webinar today. This is Penny from Wisconsin Land and Water. We're going to have John Chapman today, and John is the Senior Project Manager with raSmith, and he's going to be talking to us about the Unmanned Aerial Systems. The webinar is being presented by State Interagency Training Committee, which is part of Wisconsin Land and Water and different agency staff. And I think we're ready to go. John, are you ready?
I am ready.
All right, let's go.
All right. Thank you very much. And thank you all for joining me this afternoon. I appreciate your time. As Penny mentioned, I'm John Chapman with raSmith. I'm a senior project manager here. I manage our LiDAR and UAS operations primarily, are my job functions here. I operate out of our survey group. We have a fairly significant survey group here of about 25 to 30 individuals, most of us based out of Brookfield, Wisconsin here. And I'm going to talk today a little bit about UAS, Unmanned Aerial Systems, and some of the things we've been doing with the systems that might relate to what you all do day to day. Maybe not, but hopefully so. And let's just tear into it. I wanted to first just talk a little bit about some very basics, and that being the different types of unmanned aerial systems out there today. They're primarily made up of two different types, fixed wing and rotary aircraft, and each has its place. You know, from an raSmith standpoint, we run all rotary aircraft at this point in time, but fixed wing may be something in our future, depending on the types of applications that we run into. They all have their pros and cons. Rotary aircraft, you have more flexibility in terms of flying close to stationary objects, and of course, primarily you don't have to worry about having a place to take off from in terms of a runway type of an approach or landing. While at the same time, fixed wing gives you more flexibility in terms of the amount of area you want to cover, especially in mapping missions. But you'd be surprised what you can cover with a rotary aircraft on a mapping mission as well. Anyway, under each one of these types of aircraft, you can fly all different types of sensors, and we'll get into that a little bit here shortly. So in terms of how we're using, how raSmith is using aircraft, and maybe some other ideas here too, we primarily work our aircraft into probably 2 or 3 major categories. Operating out of our survey group, we do a lot of topographic and volumetric type survey work with our drones, and we have various different ones. The one you see pictured here is one of our units. It's made by Altus. It's called the LRX, and it's about a $40,000 aircraft. It is the drone we use for 95% of our mapping operations, and we've done a lot of vetting. We've been flying for about 4 years now, and have achieved some pretty decent accuracies, and we'll get into that a little bit here too with this particular aircraft. But we also will fly other types of missions, including inspection imagery, and I'll get into that in one of these later slides also, where we're not necessarily using an aircraft of this level of investment, and still are able to achieve some really great results. So underneath any one of these types, there's a plethora of different sensors, and this certainly is an all-inclusive list. It is just an example, but by far the most common are cameras, whether that be RGB or thermal or multispectral. There are others as well, but cameras by far are the most common type of sensor used in the UAS industry at this point in time. But there are also other types, such as LiDAR. You can run LiDAR sensors underneath these aircraft as well, and it can get a little pricey when it comes to LiDAR, but actually, just like with anything technology based, prices are coming down as the technology advances, and there's some pretty compelling technologies out there in terms of LiDAR sensors. Some obstacles that I just wanted to really briefly touch on would be your FAA certification. About 2 years ago now, the FAA rolled out their Part 107, which is a an unmanned aerial systems certification that is necessary to fly commercially here in the U.S. Unless you have a sports pilot's license or better in terms of a manned aircraft license. And I am myself am a Part 107 pilot. In fact, my certification, I got it shortly after they rolled it out 2 years ago, so I'm due to take the renewal test here before the end of October. And then something else to consider also is the insurance side of this type of technology. Highly recommend insurance. You have both hull insurance that covers your aircraft, but also professional liability insurance, which would cover things like damage that might occur if you were to, God forbid, crash an aircraft, either to the aircraft itself, to other property, or to other human beings. And then also, as a service provider, that professional liability insurance also covers us in terms of the deliverables that are derived from UAS use. So definitely, highly recommend insurance. It is really a necessity. So I'm going to get into a couple of project examples here. This first one is on the imagery side, inspection imagery side, and this was a project we got involved in through one of our engineering groups here at raSmith. Our client was Kenosha County, actually, and we were doing helping them with some imagery for Fox River stream bank inventory. They had some erosion concerns with the Fox River as it runs through parts of the county, and these various different site tags you see here are areas where the river itself was causing some severe erosion, and the county was interested in applying for some federal grant money to help them sort of mitigate those issues. And as an engineering consultant, our engineers positioned us to help them with some imagery to supplement the application that they sent in for that grant money, in the form of compelling imagery that showed how severe the erosion actually was. This is one of those sites kind of zoomed in. I want to make sure you guys are actually seeing that. Okay. And what we did actually is, as we took these images with a particular aircraft and system that we used here, each of the individual images were GPS tagged. So when a image was taken, in the metadata of the image, it actually pumped out a lat long and an elevation as well, and we were able to map semi-accurately where the drone was when we took those pictures. And then what I have is these are just a series of photographs taken from that site, kind of showing how severe the erosion was in that locale. And then I just, so you can see a little better, kind of a zoomed in view of one of those images, kind of showing that the extent of that erosion. And a drone wasn't completely necessary in a situation like this, but what it does is it gives you the ability to provide a different perspective on what might be happening erosion-wise. And this worked out pretty well from the feedback that I got from the county, and so something for you to consider in terms of use. So another use, as far as inspection imagery is concerned, would be something like this. This is a shoreline inspection project that we worked on. This is, again, down in Kenosha County, and we were asked to fly a stretch of shoreline that was owned by the county to essentially help them document the existing conditions of the shoreline so they compare it to historical imagery. There was a significant storm event. This was a little while back, but there was a significant storm event prior to this where there was some damage done in terms of erosion to this particular stretch of shoreline. And one of the beauties of using UAS in a situation like this is the fact that you can fly at such a low altitude to obtain some really highly detailed imagery. And this is just an image, but we actually created some other deliverables from this, including, you know, a DTM as well. And so if you wanted to look at things like you know, volume of shoreline material that had been moved or lost, over time. This would be a good way to do that as well. And I think it has some advantages over manned aircraft because of the fact that you can fly at such a low altitude and obtain higher res imagery. This is kind of a unique project from an inspection imagery side. We have recently been involved in a couple of different projects now where we're aiding some of our construction, inspection, engineering staff with UAS-derived services. And in this particular case, we're actually using a drone to help them with silt fence inspections on an active construction site. And this particular site was pretty substantial in size. There was almost 10,000 linear feet of silt fence installed on this site. And all that silt fence had to be inspected, or has to be inspected, at least once a week, and that's usually either by default once a week or after a significant rain event. And this site being quite large, some of the fence is easy to get to in terms of inspecting it, and other parts of it are not, especially after it had rained and everything was starting to be graded, and it gets very muddy and messy. And so using a drone, when you go out the first time, and this image inset in the upper right here, you can kind of see a path that more or less represents the path that the drone took on this one particular flight. And each one of those little tiny image tags, if you will, represents a spot in which along that path we took a photo. And then we're able to hand this information over to our construction inspection staff. And not only do they have a map where those images were taken, but they have the images themselves, and they roll that into a nice little report for the grading contractor in this particular case, which essentially enables them to very quickly identify the areas where they have some sort of an issue, and they can go out and correct it in a very timely manner. We've also experimented with tracking sediment movement across erosion control measures as well, and that kind of gets into more of a mapping aspect, but just the imagery that comes along with that can be pretty powerful. So along with sort of formal erosion control measure inspections, there's also the idea of using a drone to create or to capture imagery that more or less is just sort of construction progress. And this is another site in which we have active grading taking place, and with all the rain that the state has seen over the last month or two especially, there's a lot of interest in terms of how some of these measures are holding up. In this particular case, we're looking at a series of obviously detention ponds that have been dug, and with active grading going on. We were commissioned by the municipality within this project was being built to weekly go out and take a series of images that can be distributed to all the stakeholders to give them a feel for how construction is progressing, but also to see how these measures are holding up as we have these significant rainfall events. A lot of rain. So these next series of slides, I wanted to get into a little bit more specifics about surveying and mapping with a drone, and there's a little bit of a process here, and I'm not going to get into great detail, but I do at least want to give you a feel for sort of how this aspect works with a drone. Ultimately, when you're mapping with a UAV or a UAS, it needs to start with some mission planning, and that includes things like identifying site extents, and then when you think about photogrammetry, or I guess maybe more specifically SFM, or structure for motion, it's not photogrammetry in the traditional sense, but this is sort of the digital side of that. The software used to process that imagery is looking for very specific types of overlap from one image to the next, and the only way to get that consistent overlap is to use GPS and guidance on a drone and creating an autonomous flight plan. And there's a series of different softwares out there that can do this. all of the major drone manufacturers have their own favorites or maybe even their own proprietary software. This is one of a couple different ones that we use in terms of the screenshot. But you can see we basically have outlined a site and we were starting to create that flight plan. And this is before we've ever been on site. And so that's kind of the first step. And then from there, when you're talking about mapping, there's a number of different ways to control from a survey standpoint a project like this. We prefer, being surveyors especially, to use conventional survey controlled ground control points. And what that involves is essentially laying out control points on the ground that are identifiable from the air, and depending upon what altitude you're flying at, you may choose different types. The ones you see in the main picture here are just like 6-inch wide vinyl targets that we can create these little targets with. The one on the left is what we call a vinyl laydown target. It's a pre-made, pre-printed target. It's probably maybe 3 feet square there. And then the image on the right is a painted target, obviously on a roadway. And in that particular case, this was in support of a manned flight mission, but we use the same type of approach for many of our unmanned projects as well. And then ultimately, you have to collect, how we prefer to do it anyway, is you have to collect survey grade measurements on these points as well. And we usually use GPS, survey grade GPS, where we're going in and we're using a Wisconsin DOT prescribed method in terms of obtaining these, where we set up a GPS unit, as you see in that picture on the right, on the point, and then we pull it off. I'll spare you all the details, but ultimately we take multiple GPS observations on that particular point, and then we average all of those to kind of mitigate some of the inaccuracies that come along with GPS control. But ultimately, then you end up feeding those XYZs that you've collected with those survey instruments into that photogrammetric process on the backside to essentially give your project scale, and then also give you the ability to check those accuracies as well, which is really important from a mapping side. So this next slide just kind of shows that structure for motion or photogrammetric process kind of taking place. And in this particular case, you can see the software start to pull together where all these images are located, and it uses metadata that was stamped on the photos to help initially position these pictures where they were actually taken in flight. And then it goes through on a picture-by-picture basis, and it actually compares one pixel across all those pictures, pixel by pixel, and then fine-tunes that adjustment, and using this process of triangulation creates all these tie points. And this data underneath that you see below there in this kind of triangular shaped land pattern are all of those tie points, literally millions of tie points for this site. Those tie points ultimately form the foundation for the deliverables that come out of the back end of this process, which can include things like point cloud data or digital terrain models or even orthomosaics. So once you have this initial processing done, the next step of the process is to actually introduce those ground control points and the control that you shot on those points, as mentioned earlier. And this is just a quick screenshot kind of showing that in process. The little green arrows, if you will, in the larger graphic represent sort of where some of those control points were. And then the inset image there is essentially the software helping you to identify where it believes those control points are. And with this particular application, each individual ground control point is seen in, say, 12 or 15 different photos. And you pick the center of that control point in the first 2 or 3. And then using triangulation, it basically figures out where that same point is in the remaining 10 or 12 images that that point is visible in. And you have the ability to kind of adjust that manually through this process as well. But that ultimately is part of where the control aspect leads us to in this whole process. Depending on the application that you're using to do that processing, in this particular case, we're showing Pix4D. It's a pretty popular SFM structure for motion software out there. You're able to pump out some metrics. Pix4D calls this the quality report, and it goes through and gives you a series of metrics, some of which are easy to understand, some of which are not. But the one common mistake that I see a lot of people make, especially people who aren't real experienced in mapping with a drone, is they get this report and they see in the middle of the page here, you might be able to see these 5 green check marks, which kind of can be a little misleading, but it ultimately means you're good. But at the end of the day, trying to quantify accuracy of a flight like this has really been an issue that has kind of plagued this technology, especially as it applies to survey type projects. Just because you have a set of green check marks in a processing software doesn't mean that you're accurate, or that you're accurate to within a certain degree. The only way to really check that is to have some other way to capture measurements of that same surface with a different instrument, and then compare that on the back end. And we subscribe to some methods that were created by the ASPRS, the American Society of Photogrammetrists and Remote Sensing, and they have a set of standards that they use, including things like the 90th percentile confidence level, where you're checking multiple check shots, sometimes hundreds of check shots against that were collected with an instrument of greater accuracy, like a total station, for instance, and you're comparing those measurements to ones that were derived from the drone itself to give you a feel for what your accuracy actually is. I guess I just caution everyone out there listening that when you're doing a mapping related project, you need to be careful about how you state your accuracies, especially if you don't have a surveyor or a photogrammetry professional involved, because it can get really complicated. And if you don't know what you're doing, you can get into a little bit of trouble. So in the end, as far as process deliverables or final deliverables coming out of a piece of software like this, I kind of list them out here on the left side: orthomosaics, point clouds, a surface or a 3D model. I have, this is a point cloud that was created from a flight that we did of this site. I'm going to try and play this animation here for you. It might be a little choppy on your end, and that's okay. At the end of the day, I kind of ran through this with Penny the other day, and when we were preparing for this webinar, it worked all right. But as we zoom in, you can kind of see the level of detail. This is a site that was being filled for a client of ours up in the northern part of the state, and we used a drone to help them determine how much fill had been placed in here. And you can actually see even some of the tread or tire marks left from some of the earth moving equipment in that point cloud. And so it's pretty impressive when you really think about it. Using a drone to capture that kind of stuff. If you think about the alternative of having a surveyor do, boots on the ground walk of this pile with a total station, where maybe we're getting a point on a 50-foot grid, you're really not going to see a lot of those minor little undulations. And we really like the volumetric type surveys using drones in that capacity, because it gives us the ability to capture a lot of that kind of finite detail and give what we believe are even more accurate computations in terms of volumetrics, especially when you have bare earth or raw material exposed versus vegetation. My last slide here, I'm sorry, I think I went a little bit long, but I think we're in the ballpark anyway. This was a project I wanted to throw out there because it really uses kind of a hybrid approach in terms of the technology used to work our way through this project. This was a project up in Kaukauna on the Fox River. It was the Badger Hydroelectric Project our client was the Kaukauna Utilities. And they asked us to essentially help them map the surface, the bottom surface of the river along a certain stretch below the Kaukauna Dam. And we employed a series of different technologies on this project, including a UAS, one which we saw earlier, the Altus LRX, but we also used total station and GPS, and a Hydrone in this particular case, which is a different type of drone, a water-based drone, which helps us using sonar map surfaces beneath water. But it's kind of compelling, and I have a couple more images here. Actually, let me back up one. We obviously had coordinated with the utility on this project ahead of time to essentially interface with the Army Corps of Engineers to help us sort of control the flow of the river so that we could effectively do our jobs. When we got there, this is kind of the state of the river, and we were a little surprised because, like I said, we had done that coordination, but the river was raging at that moment. And so we got on the horn with our client, the utility, who was in touch with the Army Corps, and ultimately they knew we were coming, and they were just drawing down the river upstream a little bit to essentially give them some more flexibility in terms of lowering the flow output a little bit so that we could get in there and do our jobs after that and get in and out of there as quickly as possible. And that process took maybe about an hour. And after that hour was done, this is sort of what that same stretch looked like. It was actually pretty amazing to me. Engineers are incredible people. But anyway, we employed in some areas, we actually had some surveyors with some hip boots, and we actually did some boots on the ground survey throughout here. But you can see all of the uneven sort of rocky nature of this bottom, and that's where the drone actually helped us kind of create a more highly detailed surface here as well. And here you can see a picture where we've got some areas that had not been drawn down quite as much, and it's kind of hard to see probably, but right in this area here, sort of below the truck in the background, is actually the Hydrone itself, where we're doing a grid mission there with the boat kind of mapping the river bottom below using that sonar technology. And then, as I mentioned before, we ran a series of missions with the Altus LRX. And if none of you have ever seen a larger UAS in action, it's a little bit different than a smaller one. And I actually have a short little video clip here just kind of showing that. There's some audio here as well, which I don't know if that's coming over. Hopefully it is. This is an aircraft that you can definitely hear, even if you're flying at 3 or even up to the max of 400 feet, you can definitely hear it down below. It's a large quadcopter, but it actually has 8 blades that are inverted on top of one another over each arm. So anyway, I hope that gives everybody kind of just a real brief glimpse in terms of how this technology can be used. And I guess, Penny, with your help, maybe we can take some questions.
Great. Well, thanks, John. Yes, there are a couple questions out there. One was from Mitch up in Lincoln County. Can you briefly describe the process to become an FAA Part 107 certified? To become FAA Part 107 certified?
I sure can. So it's a test that is put out by the FAA. It's proctored by private parties all across the country. I think here in the state of Wisconsin, there's at least 7 or 10 different private entities that proctor those. Locally here, we're out of the Brookfield area. We took it with a small business right near the Waukesha County Airport. But they have outlets all across the state. But ultimately, the FAA pushes out a study guide for this test as well, which is free to download off their website. We found it a little intimidating, their study guide, and so we actually went out and found a third-party source to help us study. It's an online source, and this gentleman, he pulled together a series of videos to help you study specifically for this test. And actually, I'll just give it out right here on the webinar. It's remotepilot101.com. And if anybody wants further information on that, just email myself or Penny afterwards, and I can provide you with a link, etc. I think he charges about $150, and you get lifetime access to these videos. It's pretty in depth. Probably 10 or 12 chapters, and maybe 5 or 6 videos per chapter that are like roughly 3 to 5 minutes long each. And he really hones in on the areas of that study guide that you really need to understand in order to pass that test. So it's a 60 question test, and you have to score 70% or better in order to pass. And it's a 2-year certification. And at the end of that 2-year, you have to take a recurrent exam. Unfortunately, there is no ongoing education credits that will essentially allow you to renew. You literally have to take another test at that 2-year mark. But it's only 40 questions as far as the recurrent is concerned. So hopefully that answers your question.
Okay, hope that helps you out, Mitch. And then Adam from Washington County asked, what software solutions are you using to create maps? If any, which ones work best for you?
The method that we use and actually prefer is essentially the imagery out of the drone. We first process in Pix4D, and that gives us our basic sort of deliverables in terms of an orthorectified image, and then also point cloud data, as well as a digital terrain model if we're taking it that far. But from there, we're taking it then into a CAD package. We use AutoCAD Civil 3D primarily, although we do run a little bit of MicroStation here as well. We do a lot of different type of LiDAR processing, so we run another plugin on top of MicroStation called TopoDot, which helps us extract some basic topographic information as well. But that Civil 3D workflow, Pix4D into Civil 3D, seems to work pretty well for us. But there's a number of different ways you could go about it.
Okay. Anybody else have any questions out there? You can either unmute yourself or you can send it through that chat line. Otherwise, just a reminder, this is being recorded. So I'll post it on the Wisconsin Land and Water Media website. At some point, it's a process that we have to get it converted over. So it'll be on there. I sent out the link for the short evaluation that you can fill out. And as always, we're always looking for training ideas. We can do webinars like this, or we can do in-person trainings. So that's part of my job duties, is to provide training. So I don't see any other questions. John, that was great. I appreciate that. And I think we're going to call it a wrap. Everybody have a great day. Thank you.
Thank you very much, Penny. Thank you, everyone.
Thanks, John.